I want to do an example which is based on sets. वो यहाँ पे कहीं पे है भी से. Yeah. Okay. So here's an example of a set which is recursively defined. So I'm defining S1. This is the set that I'm trying to prove, trying to define recursively. Okay. And what I say is that 3 is in my set. Okay. This is the first fact that I tell you. This fact is space case. Okay. And then I say that if X and Y are in S1, then their sum is also in S1. Okay. Okay. Can anyone now know what S1 is? So definition says that so S1 की ये definition है. It says that 3 is in S1. एक तो ये, दूसरा part ये कि if X, Y is in S1, then X plus Y is sorry, I'm going fast. Then X plus Y is also in S.
X comma Y pair है या हम कह रहे हैं कि X भी S1 के अंदर है और Y भी S1 के अंदर है?
या पेयर नहीं है, ये दो इंडिविजुअल एलिमेंट्स हैं. ओके, X भी S में है और Y भी S में है. Okay, so do you guys know what S1 is now? So 3 is definitely there. If 3 is there, then 6 is there because 3 plus 3 is 6, right? Then 9 is there, then 12 is there, and so on. So all the multiples of 3 are in S1 by this definition. Okay, this is a recursive definition of multiples of 3. All right?
सर इससे लेकिन हमें y का कैसे पता चला कि वो भी 3 है?
क्योंकि S, so I can pick any element ना. So S1 में 3 था ना. So I say that X is 3. Right? And then 3 is there, so I say Y is 3. Okay?
तो फिर अगर हम कोई भी एलिमेंट पिक कर सकते हैं तो S1 तो डिफरेंट नहीं आएगा सबके लिए?
What do you mean?
मुझे ये समझ नहीं आई कि ये 3 के मल्टीपल्स कैसे बन गए सेट इसके.
तुम बनाने की कोशिश करो. What would you? So this is the definition and try to make S1, which is different from 3's multiple. Okay, so 3 is by definition there. और इसके अंदर क्या ऐड करोगे?
Y सर 1 भी हो सकता है, 4 5 6 मतलब.
Y 1 कैसे हो सकता है? 1 है यहाँ पे S1 में. तो conditions.
क्वेश्चन एक दफा.
So देखो, once again ये S की recursive definition है. It says that the 3 is S1. This is the first clue. Okay, and the second clue is that if X is in S1 and Y is in S1, then X plus Y is also in S1. Okay. So I pick X, which is 3, जो S1 में. I pick Y, which is 3, which is also in S1, and I make a new element of S1. Okay. Once I make 6, then I can pick 3 plus 3 6 again, and I can pick 6 plus 6 12 again, and I can pick 3 plus 6, which is 12 again. Okay.
सर यानी कि हम फर्स्ट केस के लिए ये कंसीडर कर रहे हैं कि मतलब S1 में अभी सिर्फ 3 पड़ा हुआ है और कोई एलिमेंट नहीं है.
Yeah.
उसके बाद फिर हम उसका 3 को अगर 2 दफा कर लें तो 6 बन सकता है. अगर 6 में फिर अब 6 और 3 आ गए सेट में तो 6 में 3
so
ऐड
देखो,
करें.
जो ओके, अब मैं थोड़ा सा अंडरस्टैंड. तो देखिए, जो चीज आप कंफ्यूज कर रहे हैं, आप ये कह रहे हैं कि X और Y दो डिफरेंट नंबर्स हैं, लेकिन डेफिनेशन में तो कहीं पे नहीं लिखा हुआ ना कि X और Y डिफरेंट है. कहीं पे लिखा हुआ है कि X is not equal to Y. ये तो नहीं लिखा हुआ ना. तो X and Y could be the same number from S1. The only condition is that X must be from S1 and Y must also be from S1. It does not say that they are distinct numbers. Okay, so why do you confuse it? Okay, they can be the same number. You can pick it as many times as you want, right?
Okay.
I can say X, Y, Z from S1 and they can all three be the same number. Okay, जब तक मैं आपको ये नहीं कहता कि X is not equal to Y, they can be the same number. Okay, Shaviz, are we good?
Yes, sir.
Okay. All right. So that's the definition of multiples of 3. Here's another set which says that 2 is in S2. And now if X is in S2, then X square is also in S2. Can anyone help me do this now? So S2 मैंने करना है. So I know that 2 is in S2, and then if x is in S2 implies x square is in S2. So what is S2?
Yes, sir. So
2, 4, 16.
8 नहीं
I
होगा.
think it's the even powers of 2.
8 होगा? क्या नहीं होगा?
8
How
होगा.
how do you get 8?
नहीं होगा
8 is not so
क्योंकि वो स्क्वायर है
yeah,
ही
it's not square of any element in here, so it's not there. Okay, so 16 is there.
16.
32 होगा?
No.
32 नहीं होगा. 32 is not square of anything. Okay, so you'll get 64.
256
You get
64
to
हाँ होगा
56 and so on,
सर
right?
64
Okay,
नहीं होगा 64 नहीं होगा
64 नहीं होगा.
8 नहीं
64
है
is
64 नहीं होगा
scale of 8.
नहीं तो
Yeah,
64
64 is
नहीं
not
होगा.
there. Yeah, okay, good. Okay, so it's not there. So it's uh, is there another way to write down S2?
x स्क्वायर 2 की पावर
2x plus
नहीं
1.
सर 2 की पावर
Oh no.
x
2. Yeah.
x इज इक्वल
What?
2 की पावर n ये हो सकता है
2 power
X is
x, 2 power 2x,
x इज इक्वल टू
4x
2 की
maybe.
पावर n
x is to power n.
यस
Yeah.
ये हो सकता है
Okay. All right. Okay. So this was interesting. Let's do one more. So this says that S3 says that 0 is there. Okay. So it's the base condition. And it says that if y is there, then y plus 1 is there. All right. What set is this? This one is easy.
so 0 1 2 3 4 5 6 सारे
Yeah.
For all the
पॉजिटिव
Yeah.
इंटीजर हो
numbers.
जाएंगे
Yeah.
Whole
It's
number.
n. It's the
सारे
set n. It's
पॉजिटिव
the set
इंटीजर
of all non-negative.
पॉजिटिव होल नंबर इंटीजर
Yeah. Yeah. Non-negative integers. Yeah. Okay. I think maybe there is one more. Yeah, okay, so 2 हमने कर लिया तो we understand that 2 is not in S1, 2 is definitely in S2, and 2 is also in S3. 16 के बारे में we know that 16 is in not in S1, it's in S2, and it's in S3. 21 के बारे में we know that it's in S1, it's not in S2, and it's definitely in S3. Okay, and you should practice on these. Okay, have a look at them. All right, I think we are good, unless there is a really good example. Okay, so a proposition on a recursively defined set. Okay, yeah, let's do it. It's not that hard. So S is a set. It's defined as this, that you start with 4. 4 is in your set. Now if X is in your set, then X square in your set. Okay. And the claim is that every element of your set is an even number. Okay, let
सर
me do it on a new number point. So the
Actually,
statement,
पूरा set define करने के बजाय we can like look for values and then see that if they're divisible by 2.
सर इनिशियली इवन है तो सारे स्क्वायर भी इवन होंगे हमें चेक जरूरत ही नहीं फिर
so let's see. Okay, so if 4 is in S, and then we say that X is in S implies that X square is in S. Okay.
यस
Okay, so let's try base case. Okay, base case is 4 is even, so we are good, right? Inductive step में, how would you write inductive step? I know you guys know that this is true, okay? You know how to prove it, but let me just formally do it for you, okay? What would inductive step be? How would you write inductive step?
We will like define the square for 4. 4 square is equals to 16. So 4 into 4 is equals to 16 since 4 is even.
Yeah,
4
so
into 4
So,
is
so, so the point is to write the inductive step. Okay, to write the inductive step, you would have to say that assume that x is even, and we want to show that x square is even. Okay, so where x is arbitrary. arbitrary in S. Okay. And that's know, you guys know how to compute this, right? But the thing is, the point I wanted to make is that you need to write it down, that what you are assuming and then what you're trying to prove. Okay, I think we're good. Okay, let's do this as well, maybe 5 minutes. Okay, so here's the thing. We define a set S as 0, 0 is in your set. Okay, and then we say that if a b in is your set, then a b plus 1 is in your set, a plus 1 and b plus 1 is in your set, a plus 2 and b plus 1 is in your set. Okay, so it's sort of not so simple set. Okay. Using this definition of S, you need to prove that for every pair AB in your set, A is less than 2 times B. Okay, so let's go and see what do we need to do this. What do we need to do for this one? Let me just memorize the statement so that I can write it for you guys. I hope you guys have memorized it. Okay, so let's see. Okay, so the set S is defined as follows: 0, 0. The pair 0, 0 is in S. Okay. Now, if A, B is in S, this implies that A, comma B plus 1 is in S. इसके अलावा A plus 1 and B plus 1 is in S. And then I think A, comma B plus 2 था मेरे ख्याल में.
A plus 2, B plus 1.
A plus 2, B plus 1. मैंने बाकी सही लिखे हैं?
Yes, sir.
Yes, sir.
Okay. All right. So now we need to show that.
Equal to 2B.
What?
We need to show that A is less than equal to 2B.
Yeah. So we need to show that for all A, B in S, A is less than or equal to 2B. All right. Okay. So base case is seemingly extremely simple. Okay. So base case may you have only one element, which is 0, 0. Or this case may the statement is true. Okay. Is definitely less than or equal to 2B. Now we need to show that assume A comma B in S has this property. Okay, and assuming this, we want to show that A comma B plus 1 has this property. Has this property, or A plus 1 B plus 1 has this property, which is A is less than equal to 2B. और हमने ये शो करना है कि A plus 1 B plus 2 times B.
A plus 2, B plus 1.
B plus 1 has this property. Okay, so we need to show all these cases using this. Okay, so we show them one by one. Okay, let's say this is one. So हमें ये पता है कि A is less than equal to 2B. So इस case में the B part is B plus 1. Okay, so your condition becomes 2 times B plus 1. Okay, so since A is less than equal to 2B, this thing implies that A must be less than or equal to 2B plus 2. Okay, so we are fine. Yes? The second part is that you have A में plus 1 आपने add करना है और B में plus 1 आपने add करना है. Okay, so you know that A is less than or equal to 2B. It implies that A plus 1 is less than equal to 2B plus 2. Okay, because you added 1 here and you added 2 here. Okay, so this case is true.
Yes.
3 is again you have this, and you need to show that a plus 2 is a plus 2 is less than equal to 2b plus 2, because both sides पे आपने 2 ऐड किया, so this is true as well. Okay, so let me repeat. This is it. This is done. We started with the definition of set. 0 0 is there, तो फिर recursively define के if ab is there, a comma b plus 1 is there, a plus 1 comma b plus 1 is there, a plus 2 comma b plus 1 is there. Now we need to show that for all pairs a is definitely less than equal to 2 times b. For base case, it's quite simple. It's easy. It's exactly what we want. For the inductive step, we need to assume that a b के लिए ये true है. तो फिर it's true for a comma b plus 1. It's true for a plus 1 comma b plus 1 and a plus 2 comma b plus 1. Okay? Is everyone on board?
Yes, sir.
Okay, so this is, मेरे ख्याल में this यहाँ तक का जो काम है ना, this is the trickiest part. उसके आगे सब basic algebra है. Okay, this is what you want to practice, writing down the inductive hypothesis. उसके बाद that's it. उसके बाद फिर हमने A और B की values plug करके देखी हैं कि these 3 conditions are actually true for in these 3 cases. Okay.